Students, welcome to my YouTube channel. We were discussing with electrostatics. See, electrostatics is the study of electric charges at rest. And charge is the fundamental quantity in electricity and its unit is coulomb. All those aspects we discussed. Intensity of electric field we discussed. The intensity of electric field at a point is defined as the force experienced by a unit positive test charge placed at that point. The important equation for intensity of electric field E is equal to F by Q. That is very important. Intensity of electric field E is equal to F by Q. We discussed. After that, we discussed about electric dipole and two important derivations we have done. That is the intensity of electric field due to a dipole in the axial position and equatorial position. So we have the videos in the playlist. You can check it. So I was discussing about electric dipole. So an aspect related to electric dipole only we are going to discuss. That's also very important for short note, even for numericals and for MCQs if you are preparing for common entrance test, NEET and JEE exams. So let's start on that. Before that, I will give you an idea about the what is an electric dipole, because the portion today we are going to discuss is torque experienced by a dipole. This is what we are going to discuss today. Dipole we already discussed. Dipole means, this is the simplest definition I can give you. Two equal and opposite charges separated by a very small vector distance constitute an electric dipole. Two equal and opposite charges separated by a very small vector distance. Here the vector distance is very important. It's from negative charge to the positive charge. Usually you need to understand, in electricity everything starts from positive to negative. Electric lines of force starts from positive to negative, but in electric dipole it's in the reverse way. So the vector distance, when we talk about an electric dipole, I told electric dipole is it consists of two equal and opposite charges separated by a vector distance. The vector distance, very small vector distance, is from negative to positive charge. That is very important. So if you want to see how the electric dipole, it would be like, there should be a minus q charge, there should be a plus q charge. The separation, this is known as the 2a. This distance we usually take it as 2a. This is from negative to positive. Why we are taking it as 2a means, it's for derivation and all, it would be easy when you consider it as 2a. Okay, so it is from negative charge. The vector distance is from the negative charge to the positive charge. Okay, so you understood all those aspects. Now I am going to discuss about the what would be see what is the torque. See, torque I am again explaining you. You learned it in the 11th portion. What is torque? Torque is the rotating effect produced on a body. What is torque? It is the rotating effect produced on a body. Two equal and opposite forces constitute a torque or a couple. When two equal, opposite, parallel forces constitute a torque or couple. You know it. Two equal, opposite, parallel forces constitute a torque or a couple. See, torque is the rotating effect produced on a body, and the formula for torque, tau, is equal to 1 of the force into perpendicular distance. These things you know. So this is the equation for torque. Torque is equal to 1 of the forces into perpendicular distance. Now we will come to the electric dipole. First I am explaining you why there is a torque experienced on a dipole when it is placed in an electric field. Why you are experiencing a torque why the electric dipole is experiencing a torque when it is placed in an electric field, uniform electric field. Uniform electric field means the lines of force will be parallel and equidistant. You know, lines of force, electric lines of force are imaginary lines drawn in such a way that the tangent to it at any point gives the direction of electric field. You know it. See, in a uniform electric field, the lines of force will be parallel and equidistant. That is electric lines of force, sorry, that is uniform electric field. See, next we are going to discuss, what we are going to discuss is what will happen when an electric dipole is placed in a uniform electric field. See, this is our electric field. See, I am considering, this is our dipole. This is the negative charge. Sorry, this is the negative charge, and this is the positive charge. So this is the electric dipole. So the vector distance is from minus to positive, that plus, that means this is the direction. See, we have an electric field, uniform electric field in this direction. E is the electric field. So the angle between this electric dipole and the electric field is, this is the angle theta. You can get it. To get an electric field in this direction, you will keep a negative plate, you will keep a positive plate here and you will keep a negative plate here. So the electric field will be from the positive to the negative. You understood this. So the electric field will be from the positive plate to the negative plate. So you need to understand here, this positive charge will be attracted towards the negative plate and this negative charge will be attracted towards the positive plate. So what will happen? The dipole starts rotating. The reason is, you understood, there is a force of attraction between this positive charge and the negative plate, and there is a force of attraction between the between the negative charge, and so these two forces, this is two equal opposite, this is one force here and this is another force here. So the arrow, I will keep it correctly, so this is like this. So you will, this is like this. So you have two equal and opposite forces. That is the concept of torque or couple. See, what is the concept of torque or couple? Two equal or opposite or parallel forces constitute a torque or couple. So here a torque is experiencing, you are getting it. See, one force from the positive charge to the negative plate. This is the way we create an electric field. You know it. Am I right? So this is the positive plate and this is the negative plate. You got it. Now I am coming back to the torque. See, torque, I told you, torque is equal to one of the forces into perpendicular distance. You need to understand what is the perpendicular distance here. See, you have to see it here. The perpendicular distance is, see, this you need to, this is the force, right? So the perpendicular distance is, this is the perpendicular. I am creating a triangle here. So this is the triangle. The triangle, I can, one second, I will make it clear. So this force, it is like this. You got it, right? So this one, this is your dipole. I am creating a triangle. That triangle, again, I will use the green color only I have used. I am naming it this is I am naming it with this green color. This point I am taking it as A, this point I am taking it as B, and this point I am taking it as C. So ABC is the triangle, right? C is the right angle, the triangle. C is, this angle is 90. So what is the perpendicular distance here? This is the perpendicular distance from B to C. At the point B only plus Q charge is located. At point A only minus Q charge is located. From B to C only you are having the perpendicular distance between these two forces. So what we can write? Torque, tau is equal to force into perpendicular distance. You are getting it? So what is the force here? One of the forces I have taken as F. into perpendicular distance is into BC. This is the formula. So you got it. Now you know the formula. You can understand here E is equal to F by Q. This is a very important equation. We learned it already. We derived this equation as well. Please watch the previous videos. E is equal to F by Q. Then what would be F? When you cross multiply this, you will get it as F is equal to E into Q. I am substituting here, so I will get E Q into BC. So and now I want to find out the distance BC. See, you have this angle as theta. You need to understand here. So this is, I am drawing another parallel line like this. Then this is a diagonal. This line is a diagonal. This is theta. This angle is also theta. You got my point? When a parallel line is cut by a diagonal, sorry, just 1 second. Yeah, when a parallel line is cut by a diagonal, you know this angle and this angle are equal. You know, you learned it in the school. So this angle is theta, this angle is also theta. From here I can consider, see, I need to get the distance BC, so I have to take sine theta. Sine theta is equal to opposite side by hypotenuse. Opposite side is BC divided by hypotenuse is AB. AB, opposite side by hypotenuse. You are able to see it, correct? So sine theta is equal to BC by, I will make it correct properly. So sine theta is equal to BC by AB. So what is BC? BC is, you can understand here, BC is, we need to calculate BC only, we need it. So cross multiplying, BC is equal to AB into sine theta, correct? So what is AB? AB is the length of the dipole. I already told you, length of the dipole we are taking it as 2A for the no, it is for, in the equatorial position, axial position, that derivation is there in the playlist. To make the things easy, we take, usually we take the length of the dipole as 2A. Okay, so AB I am taking it as 2A, that is the length of the dipole, 2A into sine theta. Then I can substitute here. So EQ into BC is, I am substituting 2A sine theta, right? BC is 2A sine theta. So we got it. See, you need to understand, we in the last video, we discussed about a physical quantity known as dipole moment. See, what we discussed is dipole moment. You may be familiar, dipole moment. You need to watch the previous video. What is dipole moment is denoted by the letter P. What is dipole moment? Dipole moment is the product of one of the charges. In the case of a electric dipole, product of one of the charges and the vector distance between the charges. That means dipole moment, you know it, I told you, dipole moment P is equal to one of the charges Q into 2A. This is the formula. 2A is the distance, 2A. Q into 2A. So Q into 2A is the distance. So this is the formula for dipole moment. P is equal to Q into 2A. So here you have, see, if you see here, 2AQ. So this is P. Dipole moment is a vector quantity. See, this is because A is a vector quantity. You know, charge is a scalar quantity. You know that. So I can substitute here. So instead of Q into 2A, I will substitute P. So I can here again, I can write it as E into P into sine theta. This I can rewrite it. So I will write it in red letter only. Then you will understand. So here I have, so it is E into P into sine theta. I have written that. So you know what is A cross B. You know the vector product and scalar product. If you don't know those concepts, you please learn it, because these things, it is really important for physics and even for math. So what is so vector product? If you have two vectors, A cross B is equal to AB sine theta. You know that A cross B is equal to AB sine theta. What is A dot B? A dot B is equal to AB cos theta. So with this concept here you have, instead of A you have E, instead of B you have P, so EP sine theta. That means it is E cross P. So I can write it as this as equal to E, this is E cross P. So we got the final equation. This is the final equation I can write. So the final equation, this is really important. So the torque 2 is equal to, I am writing vector form, E cross P. This is the final equation, you will get it. I will write it properly. You can see it as vector torque tau is equal to E cross P. This is the cross product. Torque is a vector quantity. So from this, what you can understand is torque tau is equal to E cross P. That means the torque, the rotating effect produced on an electric dipole, is the cross product of the intensity electric field vector, that is intensity of electric field or electric field, E electric field vector, and P is the dipole moment. It's very important. P is dipole moment. See the electric field vector and the dipole moment vector. So torque tau is equal to electric field vector and the dipole moment vector. That is the equation for the torque. So the summary, it is electric dipole. I am summarizing all the points we discussed. See, electric dipole means two equal and opposite charges separated by a very small vector distance. The vector distance is from the negative charge to the positive charge. The next point you need to understand is dipole moment, represented by P. Dipole moment is the product of one of the charges and vector distance 2a. So P is equal to 2q into a. Now when an electric dipole is placed in a uniform electric field, it will experience a torque, or it starts rotating. The torque is the fundamental formula from the classical mechanics. Torque is one of the forces into perpendicular distance. So when we apply that concept to the electrostatics, you will get torque is equal to E cross P. This is very important for short note questions. For numericals, you can get numericals in your board exams, and it is really important for multiple choice questions. Okay, that's all about the torque experienced by a electric dipole when it is placed in a uniform electric field. Once again, uniform electric field means the electric field is same everywhere. That means electric lines of force are parallel and equidistant. So that's all for today. So that's the this is the intensity of this is the torque on an electric dipole. Thanks for watching. Thanks a lot. Please share, like and subscribe. Thanks a lot.